Good morning. Now, the second problem on combined spectroscopy is C7H7NO2. So, other data is also given. They have given this IR data and they have given this PMR data also. So, how we can solve this problem? So, first of all, you have to go for the ISD. For getting the ISD, the formula is 2x plus 2 minus y divided by 2. So x stands for carbon and y stands for it is hydrogen. So we can put this value in this equation, but there is one element is given, that is nitrogen. So for that nitrogen, you have to add CH in the molecular formula. So that molecular formula becomes C7H7N. So we have to ignore the oxygen, so we have to add CH. So what it becomes, the molecular formula becomes C8H8. Okay, and oxygen is there, so this is C8H8. So we can put this value in this formula. So 2 into 8 plus 2 minus 8 by 2. So 8 to the 16, 17, 18. So it comes to 18 minus 8 divided by 2. So answer comes 5. So again, what we conclude from this one, we conclude the given compound is unsaturated and there are 5 unsaturation, more than 6 carbon atoms are there, so we can say it is a aromatic compound, aromatic containing benzene. So this is a conclusion we can draw. So maybe there. So the second is the IR. Always you go this IR for the last because we don't remember these values. I know these values because this is for the aromatic, this is for aliphatic, this is again aromatic stretching, and then 850 and to 800, this is again it's a disubstituted compound. But at this moment, suppose we are not remember this value, so we can go for the PMR directly. So in the PMR, the first signal they have given is singlet 3 hydrogen atom. So I should write first of all the 3 hydrogen atom, and it shows the singlet. It means there is one carbon, but there is no proton on this. So this shows the singlet. The second singlet, they have given the data for the PMR spectroscopy is nothing but the doublet 2 hydrogen. So I can write there are 2 hydrogen atoms are present, and these 2 hydrogen atom they shows the doublet. The meaning is there is a one more hydrogen present. So but you can look at here, the value is 7.5, and always this 7.5 delta value, it indicates the aromatic compound. So instead of writing this CS2 doublet, so I can take directly the aromatic compounds from this PMR data value, and what I can write, there is one proton present and there is also a similar one more proton present, and among these there is a proton and again proton, and these two protons identical. This is A, this is A, this is proton B, this is proton B. They are identical. So these two proton, they are showing doublet. So it's 7.5 value. Again they have given the third signal is doublet 2 hydrogen atoms and 8.5. Again it means it is a aromatic proton, and same value I can see it here is here. These two protons are identical, yes, because there is a substitution present at para. So that's why these are the two proton is given. Okay, so this proton and this protons, they have the identical environment, and that's why if you take this it shows the 1 plus 1, that is doublet, and this is also shows the doublet. So there are two proton doublet, and again these two protons are doublet. So this kind of para substitution is present. Now after this we can join these two fragments. And how we can join this program? So I can take benzene, it is a para substituted, one proton here, another proton here, this proton, I can write. Then there is a para substitution. Okay, then we can see how many carbon atoms are now involved here? 1 is 6, and how many carbon atoms are present? 7. So there is only one carbon is there, and the first signal shows there is a methyl group present. So I can directly write here the methyl group. This is the methyl group present. Now what is left? Number of carbon हो गए आपके 7, and you can talk about the number of hydrogen. So these are 4, 5, 6, 7. Hydrogen is also 7. Now what is left? Only NO2. So I can write NO2 directly here. Okay, and then now we can see whether our problem is correct or not. See, this hydrogen shows doublet. Yes, this hydrogen also shows doublet. This shows singlet, and there is only 3 peaks. Okay, so why these two hydrogen, this and this, they shows the difference in the delta value? Why? Because you see there is a strong electron withdrawing group present this side, so it will signal goes to the downfield. It means this value is 8.5 ppm. Okay, and for this proton, and this is the value for these two proton, and the value for this proton is 7.5 ppm, because this methyl group is donating. So this is shielding and this is the disagreeing, and that's why these two values are different here. So finally this is the structure. Then because now everything is matched, because there is a 5 unsaturation, this is 1 2 3, and there is in NO2 there is 1 unsaturation, because in NO2 the structure is this, so it means there is 1 unsaturation is present in NO2, you know, and that's why there are 5 unsaturation. Now finally we go for the PMR data. In the PMR data, so we can write it